Hey everyone, in this video I'll be describing reactions and solutions. Now, there's three types of solution reactions that you may encounter. The first type is a precipitation reaction. There is also an acid-base reaction and an oxidation-reduction reaction. Now, we'll also be considering the types of equation used to represent reactions in solutions. Now, there's three types of equations used to describe reactions in solutions. You have your formula/molecular equation, and what that is that you have everything written down as molecules in your equation, and you just have to make sure that your equation is balanced. Your second type is your complete ionic equation, and now to get this, you would break up the aqueous species in your molecular equation. You would break up these aqueous species into ions. Now, you have to only make sure that you are breaking up your aqueous species. You would leave your liquid, gas, and solid compounds alone, but you would still respect the balancing. And finally, you have your net ionic equation, which is just canceling what is identical on opposite sides of your reaction. Now, we're going to be doing two quick examples. Alright, so if we take the example of when aqueous potassium chromate, so let me just write this compound down, aqueous potassium chromate mixed with aqueous barium nitrate to produce precipitate plus potassium nitrate. Now, this equation is already balanced, and you always want to make sure that you balance it before getting your complete ionic and your net ionic formula. So we would say that this right here is our molecular formula. Everything is balanced. It seems all right. So now moving on to your complete ionic, you would basically right now we're going to be breaking down all our aqueous species into ions. So we see that potassium chromate is an aqueous. We will be breaking it down into its ions. So this is going to be, there are two molecules of potassium, so it's going to be 2K. The charge is a positive one, group 1. Aqueous solution plus chromate. The charge on chromate is -2. Now, the only way to know the charge on chromate, because it is a polyatomic ion, you have to know your polyatomic ion, so it's really essential, and I recommend you memorize them. So now we move on to our other compound, barium. Barium is going to be a 2 plus nitrate. There are two molecules of nitrate. Another polyatomic ion, very important to memorize. You encounter it quite often. Your solid right here, you leave it alone, but so you would just write it down as is. Running out of space here. Plus, right now you have your 2 potassium plus your NO3 Alright, so that's your formula right there, your complete ionic. Alright, so now what you would do for your net ionic, this is only those involved directly in the reaction, meaning you would not, right now you would be canceling out what you see identical on opposite sides. So I'm going to be taking a different color so I can distinguish the two. Alright, so now you see, just to be clear, these are your reactants. Alright, so now on your product side you have your 2 potassium, you cancel out with this, and then you have your chromate. Nope, you have no identical chromate on the other side, and then you have your 2NO3. So basically all you're left with is this, your barium and your barium chromate. You would just write it down as your net ionic. So aqueous plus chromate yields barium chromate. So now, these are called the spectator ions. They do not take part in the reaction. So there's your net ionic equation. Now we'll just be doing one last example. It's very simple. All right. So now, if we take our next example, is going to be sulfuric acid, so H2SO4 plus aluminum hydroxide plus H2O aluminum sulfate. Aqueous. All right. Now, our molecular formula equation, we realize that this is not balanced. And now to balance this, we would just add a 6 over here. 3, 2, and there we go. It looks fine to me. All right. So now we can move on to our molecular equation. Sorry, our complete ionic. This is our molecular equation. It's balanced. Now our complete ionic equation would be breaking them up, the aqueous species, into their ions. So now we have 6 hydrogens. 2 times 3 is 6. 6 hydrogens. The charge is positive, group 1. Don't forget to write your states down. Plus 3 sulfates, charge is 2 minus. There's another polyatomic ion worth memorizing. Plus 2 aluminum. The charge on aluminum is 3 plus. Plus 6 hydroxide. It's both aqueous. Yields. Realize how H2O is in the liquid phase. Course. So we're just going to be writing 6H2O liquid plus 2 Als, charge is 3 plus, and finally we have sulfate, but we have 3 of them, the subscript at the bottom. The charge on sulfate is 2 minus. Alright, so this is our complete ionic equation. Alright, now if we move on to our net ionic equation. Okay, just to distinguish the two, this is the reactant side. Alright, so now if we see what's identical on opposite ends, we'll be able to say that this crosses off, as well as the aluminum. So now we're left with hydroxide, water, and your 6 H's. We'll be writing this down, so you'll be getting 6 H plus 6 OH minus aqueous gives 6 H2O liquid. Alright, and notice how we can divide this, just reduce it, divide it all by 6, and we'll be getting H plus OH minus yields H2O. Alright, and there you go. Your spectator ions are Al3 plus and SO4 2 minus. So I hope this was helpful, and have a good day. There's more to come. Bye. Thanks for watching.